important organic parameter, that is hyperconjugation, which was observed first by the scientist Baker-Nathan observed that the alkyl group at least having one alpha hydrogen when conjugated to a double bond system releases electron by a mechanism just opposite to inductive effect. Opposite to inductive effect. That is, the order of releasing of electron is opposite to inductive effect. He named this phenomenon as a hyperconjugation and named scientist Baker-Nathan as hyperconjugation. We know that in inductive effect, the electron releasing order is a tertiary alkyl greater than secondary alkyl and greater than primary alkyl. But in case of hyperconjugation, what has been observed by the scientist Baker-Nathan, the electron releasing order is primary alkyl greater than secondary alkyl and greater than tertiary alkyl, which is just and hence the inductive effect and hyperconjugation are completely contradictory to each other. That's it. Completely contradictory each other. It's a complete different phenomenon. Let us write down, define hyperconjugation. It is a phenomenon in which alkyl group having at least one alpha H when conjugated to a unsaturated system releases electron by a mechanism called hyperconjugation. Let us draw the hyperconjugating structure. This is the conjugate. This is a unsaturated system and alkyl group having 3 alpha hydrogen is conjugated to this double bond system. This is H1, this is H2, this is H3. In the first structure, H1, the sigma bond electron of a carbon and H1 hydrogen participate in this resonance in this manner. H1 remains as H plus, first hydrogen. This is the structure for, this is the first structure, this is the second structure, this is the third structure, and this is the fourth structure when this is H2 hydrogen, the H3 hydrogen participate. These are 3 hyperconjugate structures. These are 3 hyperconjugate structures of this compound. And the electron release, this alkyl group have 3 alpha hydrogens, hence the number of hyperconjugate structure is 3. Let us take another example where the alkyl group has 2 alpha hydrogens, H1, H2 and another CH3, C double bond CH. This H1 participate in the resonance, H2, C, H1 plus, CH3, double bond C, C minus. And another hyper structure can be possible taking H2 as H1, C, H2 plus, CH3, double bond C, C minus C. These are the 2 hyperconjugating structures because this compound has only 2 alpha hydrogens. Therefore, the number of hyperconjugate structure is 2. This leads to conjugate that the maximum number of hyperconjugating structures is equal to number of alpha H. First conclusion. And in this phenomenon, the sigma and pi interaction takes place because the sigma electron of carbon and hydrogen bond participate with the pi bond. This participate with the pi bond. Therefore is called the sigma pi interaction. It is also called sigma pi interaction because sigma bond electron of carbon hydrogen participates in the resonance with the pi orbitals. Therefore, it is called sigma pi interaction. Third, as the magnitude of this hyperconjugation being smaller than resonance, it is also called the secondary resonance. As the magnitude of hyperconjugation is smaller than that of resonance, it is called second order resonance. Hyperconjugation is called as second order resonance. Fourth point, we have seen in the hyperconjugated structures that there is no definite bond between one hydrogen and carbon atom. In each structure there is no definite bond between carbon and hydrogen atom. Hence, it is also called the no bond resonance. As there is no definite bond between carbon and one hydrogen, it is called no bond resonance. But it is important to note that in each structure H remains as a H plus. It does not indicate that the compound is acidic in nature. Fifth point, though hydrogen remains as H plus in each structure, it will be not treated as acid. It is not treated as acid because its structure is a mental phenomena. To explain the properties. Therefore, it will not treated as acid. This is the hyperconjugation what has been proposed and observed by the scientists Becker and Nepthan. And this hyperconjugation has vast application in the organic compounds. That is, it explains the acidity, basicity of the compound. Also, it affects the rate of reaction also of the organic compound in certain cases. Therefore, hyperconjugation takes much importance in the organic chemistry.